Hey there, ever wondered how your messages get from your phone to your friend's screen, or how your favorite streaming service knows just what you want to watch next? It all comes down to something called the OSI model. Welcome to the OSI model, the unsung hero of modern connectivity. It's the backstage crew that ensures your emails reach their destination, your video streams smoothly, and your online games run without a hitch. But what exactly is this model, and why should you care about it? 7 layers of OSI model are: physical, data link, network, transport, session, presentation, and application layer. I am going to explain OSI layer with a story. Once upon a time, in the digital realm, there was an email named "Greetings from Pune." It wanted to travel from a computer in Pune to a friend's computer in Mumbai. First, "Greetings" was dressed up by the application layer in a fancy suit called MIME. Then, the presentation layer gave it a passport with the right address. The session layer booked a ticket for "Greetings" on the transport layer's reliable train, TCP. The network layer gave "Greetings" a map with directions to Mumbai, using IP addresses as landmarks. The data link layer packed "Greetings" into a sturdy suitcase called a frame. Finally, the physical layer put the suitcase on a train that traveled through cables and wires. After a long and exciting journey, "Greetings" arrived safely at its destination in Mumbai. The friend's computer unpacked the suitcase, read the email, and smiled. The physical layer is the first layer in the OSI model. It handles the actual hardware connection between devices, and is responsible for sending and receiving raw data, bits, over a physical medium like cables or radio waves. Let's go through each key function of the physical layer with examples. 1. Bit transmission converts data into signals, electrical, optical, or radio, for transmission over a physical medium. Example: when you send an email, your computer converts the email data into electrical signals that travel through Ethernet cables to reach the recipient's computer. 2. Data rate control manages how fast data is transmitted, measured in bits per second. Example: your internet service provider, ISP, might offer a plan with a data rate of 100 megabits per second, megabits. This means your connection can handle transmitting 100 million bits of data per second. 3. Synchronization ensures that the sender and receiver are in sync, so data is transmitted and received correctly. Example: when streaming a video, synchronization ensures that the video data packets arrive in the correct order and at the right time, so you experience smooth playback without interruptions. 4. Physical topology explanation defines the layout of devices in a network, such as star, bus, ring, or mesh configurations. Example: in a star topology, all devices are connected to a central hub. This is common in home networks where multiple devices, like computers, smartphones, and smart TVs, connect to a central router. 5. Transmission medium explanation specifies the medium used for data transmission, like cables, fiber optics, or wireless. Example: Wi-Fi uses radio waves as the transmission medium to connect your devices to the internet wirelessly. Alternatively, fiber optic cables use light signals to transmit data at high speeds over long distances. The data link layer is the second layer, layer 2, in the OSI model. It is responsible for the node-to-node delivery of data, ensuring that data is transferred reliably across the physical link connecting network nodes. Here are the functions of the data link layer explained with examples. 1. Framing: it divides the data received from the network layer into manageable units called frames. Example: think of frames as envelopes containing data packets, with each envelope having a sender and receiver address. This helps in organizing and managing the data for transmission. 2. Addressing adds physical addresses, MAC addresses, to the frames to ensure they reach the correct destination. Example: similar to adding a unique PIN code to an address. This ensures that the data is delivered to the correct device on the network. Error detection and correction. Detects and corrects errors that may occur during data transmission. Example: like checking for spelling errors in a letter and correcting them before sending it. Flow control manages the rate of data transmission between sender and receiver to prevent data loss. Example: ensuring that a fast speaker slows down so a listener can keep up. Access control. What it does: determines which device has control over the communication channel at any given time. Example: like a traffic light controlling the flow of vehicles at an intersection. This ensures that data is transmitted in an orderly manner, preventing collisions and ensuring smooth communication. Data link layer devices are switch and bridge. The network layer, Layer 3, in the OSI model ensures that data packets are delivered from the source to the destination across multiple networks. It manages routing to ensure efficient delivery. Key functions of the network layer. Routing determines the best path for data to travel from source to destination. Example: imagine you are sending a package from Pune to New York. The Postal Service determines the best route for the package to travel, considering factors like distance, traffic, and efficiency. Similarly, in a network, routing algorithms find the most efficient path for data packets to travel from the source device to the destination device. Logical addressing assigns IP addresses to devices to identify them uniquely on a network. Example: think of IP addresses as unique postal addresses for devices. Just as each house in a city has a unique address to ensure mail is delivered correctly, each device on a network has a unique IP address. For instance, when you type a website URL, your computer uses the IP address to find and connect to the correct server hosting the website. Packet forwarding moves packets from one network to another until they reach their destination. Example: imagine sending a letter from Pune to New York. The letter passes through various post offices before reaching its final destination. Similarly, in networking, data packets are forwarded through multiple routers and networks until they reach the destination device. Fragmentation and reassembly breaks down large packets into smaller fragments for transmission and reassembles them at the destination. Example: suppose you have a large package that needs to be shipped. You break it down into smaller boxes for easier handling and shipping. Once all the boxes arrive at the destination, they are reassembled into the original package. In networking, large data packets are fragmented into smaller pieces for transmission and then reassembled at the destination to form the original data. Devices in the network layer is routers. Direct data packets between different networks, making routing decisions based on IP addresses. Example: a home router directs internet traffic between your devices, like computers, smartphones, and smart TVs, and the internet. It ensures that data packets from your devices reach the correct destination on the internet and vice versa. The transport layer is the fourth layer in the OSI model. It is responsible for providing reliable data transfer services to the upper layers. This layer ensures that data is delivered error-free, in sequence, and with no losses or duplications. Segmentation and reassembly breaks down large data streams into smaller segments for transmission and reassembles them at the destination. Example: imagine you are writing a very long letter to a friend. Instead of sending the entire letter in one go, you divide it into multiple pages and send each page separately. When your friend receives all the pages, they put them back together to read the complete letter. Similarly, in networking, large data streams are divided into smaller segments for easier transmission and then reassembled at the destination to form the original data. Connection control. What it does: establishes, maintains, and terminates connections between devices. Example: Think of making a phone call. First, you dial the number to establish the connection. During the call, you maintain the connection while you talk. Finally, when the conversation is over, you hang up to terminate the connection. In networking, the transport layer handles these steps to ensure a stable and reliable connection between devices for data transfer. Flow control. What it does: manages the rate of data transmission to prevent overwhelming the receiver. Example: imagine you are filling a water tank through a pipe. If the water flows too quickly, the tank might overflow. To prevent this, you adjust the flow rate to ensure the water fills the tank at a manageable pace. Similarly, in networking, flow control adjusts the rate of data transmission to ensure the receiver can handle the incoming data without being overwhelmed. Error control. What it does: detects and corrects errors in the data during transmission. Example: think of proofreading a document before sending it. You check for spelling and grammatical errors and correct them to ensure the document is error-free. In networking, error control mechanisms detect any errors in the transmitted data and correct them to ensure the data received is accurate and reliable. Multiplexing. What it does: allows multiple applications to use the network simultaneously by assigning unique port numbers. Example: imagine you have a single cable TV connection that provides multiple channels. Each channel is assigned a unique number, allowing you to switch between different channels without interference. Similarly, in networking, multiplexing assigns unique port numbers to different applications, enabling them to use the network simultaneously without conflicts. The session layer is the fifth layer in the OSI model. It is responsible for establishing, managing, and terminating sessions between applications. This layer ensures that communication sessions are maintained and synchronized, providing a structured means for data exchange. Session establishment, maintenance, and termination. Function. The session layer establishes, maintains, and terminates communication sessions between applications. Example: imagine making a phone call. First, you dial the number. That is establishment. Then you have a conversation. This is maintenance. And finally, you hang up, and it is termination. Dialogue control. Function. Manages communication between devices, determining whether it's one-way, half-duplex, or two-way, full duplex. Example: half-duplex. Like using a walkie-talkie, you can either transmit or receive, but not both simultaneously. Full duplex. Similar to a phone call, you can talk and listen simultaneously. Token management. Function. Token management prevents multiple devices from simultaneously attempting the same critical operation. How it works: only one device at a time holds a special token, granting exclusive access to perform the operation. Example: think of a group discussion where participants use a talking stick. Only the person holding the stick can speak, ensuring orderly communication without interruptions. The presentation layer is the sixth layer, layer 6, in the OSI model. It acts as a translator between the application and the network, ensuring that data is presented in a readable format for both the sender and receiver. Functions of presentation layer are translation. What it does: translation involves converting data from one format to another, especially when transmitting data between different systems or protocols. Example: imagine you're sending a text file from a computer using the ASCII character encoding, commonly used in English, to another computer that expects data in EBCDIC encoding, used in mainframes. The translation process ensures that the data is correctly converted from ASCII to EBCDIC, allowing seamless communication between the two systems. Data compression. Data compression reduces the size of data to save bandwidth during transmission and improve overall speed. Example: before sending a large file, like a high-resolution image or a video, over the network, you can compress it using algorithms like zip or gzip. This reduces the file size, making the transfer faster and more efficient. Encryption. Encryption transforms plain data into a scrambled form, ciphertext, using an encryption algorithm and a secret key. It ensures data confidentiality during transmission. Example: when you visit a secure website, like online banking, your browser encrypts data, such as login credentials, before sending it to the server. This prevents unauthorized interception. Decryption. Decryption reverses the encryption process, converting ciphertext back to plaintext. Data formatting. Data formatting ensures that data is correctly structured and presented according to the requirements of the receiving application. Properly formatted data ensures seamless communication and accurate processing. Example: consider image files. If an application expects images in PNG format but you have JPEG files, data formatting involves converting those JPEG images to PNG format. This ensures compatibility and consistency for the receiving application. The application layer is the seventh and topmost layer, Layer 7, in the OSI model. It provides the interface between the application software and the network, enabling end-user applications to communicate over the network. Functions of application layer are network services. Network services provide various functionalities directly to end-user applications. These services enhance communication and data exchange over a network. Example: email service allows users to send and receive emails. SMTP, Simple Mail Transfer Protocol, is an example of a network service used for email communication. Next is application protocols. Application protocols define rules and conventions that applications follow when communicating over a network. These protocols ensure proper data exchange. Example: HTTP, Hypertext Transfer Protocol, used for web browsing. When you visit a website, your browser communicates with the web server using HTTP. Functions of application layer are: data representation. Data representation ensures that data is presented in a readable format for both the sender and receiver. A properly formatted data allows seamless communication between different systems. Example: imagine you have a database that stores information in binary format, zeros and ones. But you need to create a report in a spreadsheet program that requires data in ASCII text format. Data representation involves converting the binary data into ASCII text so that the spreadsheet program can interpret and display it correctly. This ensures compatibility and readability for both humans and machines. Quality of service. COS. COS refers to the set of techniques and mechanisms used to manage and prioritize network traffic. Its goal is to ensure reliable communication by maintaining consistent performance levels for different types of data. Example: prioritizing video streaming traffic. Imagine a home network where multiple devices share the same internet connection. Here's how COS can make a difference.